Assalamualaikum and hi. In this video, I'm going to talk about frequency distribution. In chapter 3, we are dealing with quantitative variables. As you can see here, on the left side, we have ungrouped data. Meanwhile, on the right side, we have grouped data. Okay. This is actually a frequency distribution table. And once you have do this is considered as group data. And all of these values originated from the left side here. When working with large quantitative data sets, it is helpful to organize and summarize data by constructing a table called a frequency distribution, just like those for qualitative data. However, since these data have no natural categories, we divide the data into classes. Okay, what are classes? Classes are intervals of equal width that cover all values in the data set. Data presented in form of frequency distribution are called group data. In this slide, let's look closely what are classes. As you can see here, there are 4 classes. This is the first class, second class, third class, and fourth class. The lower class limits of a class is the smallest value that can appear in that class. In this case, the lower limit of the first class is 0. The lower limit of the second class is 5. The lower limit of the third class is 10. The lower limit of the fourth class is 15. The upper class limits of a class is the largest value that can appear in that class. Okay, all of this here, 4, 9, 14, and 19 are the upper class limits for each class. The class width is the difference between consecutive lower class limits. What is class width? Class width is how many, we can say how many elements in each class. For example, when you look at the first class, it ranges from 0 until 4. Basically, the class width is 5 because 0, 1, 2, 3, 4. There are 5 values. Okay, once again, 0, 1, 2, 3, 4. 5 values. And you can check that for each class, the class width is 5. Okay, let me demonstrate one more time for the third class. Okay, if you count from 10 until 14, there are 5 values. Okay, 10, 11, 12, 13, 14. Okay, so that is class width. Now let's look at what is class boundaries. Class boundaries are the numbers used to separate classes, but without the gaps created by class limits. It is given by the midpoint of the upper limit of one class and the lower limit of the next class. For example, as you can see here, the upper limit of the first class is 4, and then the lower limit of the next class is 5, and then 4 plus 5, 9, over 2, okay, 9 divided by 2 is 4.5. So the class boundary, the upper class boundary for the first class is 4.5. Meanwhile, 4.5 will be the lower class boundary for the second class. Okay, so 4.5 will be the upper class boundary for the first class, and also it will be the lower class boundary of the second class. And then for the upper class boundary of the second class will be 9.5, and then 9.5 will be the lower class boundary of the third class, and so on. Class boundaries are also called as the real class limit. And then we have the class midpoints are the values in the middle of the class and can be found by adding the lower class limit to the upper class limit and dividing the sum by 2. That means the class midpoint of the first class, okay, let me write here. The class midpoint of the first class is simply 0 plus 4, which is 4 over 2. So the class midpoint is 4 over 2, which is 2. And then 5 plus 9, 14 over 2, which is 7. And then 10 plus 14 equals 24 over 2. We get 12. And then 15 plus 19, 34. 34 over 2 is 17. Okay, so these are the class midpoints. Now let's look at exercise 1. Determine the variable, the frequency, the class width, the lower limit of the fourth class, upper limit of the sixth class, boundaries of the third class, and midpoint of the second class. Please work on these questions, okay? Now let's look at how to construct a frequency distribution. Step 1, choose number of classes. Use Sturgis formula. Okay, C equals 1 plus 3.3 log n. Okay, where C is number of classes, N is number of observations in the data set. And then in step 2, choose a class width, where class width denoted by I must be greater than range over C. Okay, for example, if you get your calculation greater than 18, then your I should not be 18. This is wrong. Okay, but I must be greater than 18. So it must equals to at least 19. Okay, or another example, let's say you get I greater than 18.1. Okay, so you should not choose your I to be 18. This is wrong. Okay, because I must be greater than 18.1. So you must choose I at least 19. Okay, step 3, starting point. You must choose a starting point. For this course, you must choose the minimum data value, the smallest data value, okay, as the first lower class limit. Step 4, find the lower limit for the second class by adding the class width to the lower limit of the first class. Okay, we will see about that soon. Step 5, find the lower limits for each of the remaining classes by adding the class width to the lower limit of the preceding class. Stop when the largest data value is included in a class. Okay, count the number of observations in each class and construct the frequency distribution. Let's use this data in example 1 to construct a frequency distribution. It's the data of home runs hit by Major League Baseball teams during the 2004 season. In example 1, we have 30 observations. Okay, as you can see here, n is 30. Okay, and then remember step 1 is to calculate the number of classes using this formula 1 plus 3.3 log n. Log n is log 30. Okay, now use your calculator. You will get 5.87. Okay, so you will decide the size of classes will be 6 classes. Okay, as you can see here, we have the first class, okay, second class, third class, fourth class, fifth class, and the sixth class. Okay, and then the next step is to choose the starting point, okay, or the lower limit of the first class, okay, and for your convenience, simply choose the smallest data value, which is 135. Okay, and then you have how are you going to decide on the upper limit? Okay, will be 135 I'm sorry, before that we must calculate the value of I. I must be greater than range over C. Okay, I must be greater than. Okay, what is range? Range is simply the largest value minus the smallest value. Okay, that is range. Okay, over C, whatever you have calculated earlier, which is 6. Okay, in this case, I will be greater than, if you look back at the data, the largest value is 242 and the smallest value is 135. Okay, over C. Now use your calculator. You will get 17.83. Okay, so thus you must choose I to be at least 18. So I will be the class width. Okay, so in order to decide the upper limit of the first class, okay, we will add 17 more. We will add 17 more to 135. Okay, that's why we get 152. Okay, kenapa kita tambah 17 sahaja? Sebab kelas width ni adalah bilangan daripada 135 sehingga 152. Okey, kalau awak kira 135, guna jari awak. 135, 136, 137 sehingga 152 kena ada 18 18 jari tu. Sebab tu since 135 kita dah satu jari kita. So yang tinggal kita tambah 17 sahaja. Okey, untuk dapat 152. Okey, macam tu cara dia. Okey, dan seterusnya untuk second class, since dekat sini 152, awak kena start dengan next number 153. Okey, 153 dan lagi sekali hanya tambah 17. Sebab tu awak dapat 170. Okey, sebab kelas week kita 18. So sebab 153 kita dah kira satu jari, kita hanya tinggal untuk tambah 17 jari je lagi. Okey, untuk menjadikan kelas week kita 18. Kemudian untuk frekuensi ni, kita kira daripada data kita. Data kita yang 135 sampai 152 ada berapa? Ada berapa semua tu? Ada 10, 2, 5 dan sum dia mesti 30. Okay, so I'll stop here for today. And I really need you to understand the process of constructing the frequency distribution table from example 1. Okay.